your first time talking to.
Hello, my name is Gurvir. I'm the moderator for today, and this is the RoboRIO wiring and sensors presentation. We're joined by two amazing speakers, Navid and Andrew.
Hi guys, my name is Navid. I am currently a second year student in Columbia University in New York, studying mechanical engineering and physics. I have been part of FRC for around 5.5 years now. I was a student on FRC 694 Post in New York City, and I'm currently a mentor for them.
Hello, everybody. I'm Andrew. I'm a senior at Davies Senior High School. I am a member of FRC Team 16 Same-Day Citrus Circuits. I am currently a third-year electrical student.
So, as we said, the title, we're going to be talking about mostly the electronic system, control system of your robot today. Specifically, we're going to have an in-depth discussion about the RoboRIO and talking about different wiring methods for our teams, as well as sensor usage on our robots. But right now, we're going to be talking about the FRC control system. So the current control system that all teams are required to use, it has been around since 2015. Before that, we used a different system completely with the serial, and before that, even a custom electronic system per team. Currently, most of the electronics is developed by CTRE Electronics, and but the RoboRIO is developed by National Instruments. If you look in this diagram, it gives a basic guide on the main parts of the control system and how to wire them. Some things that aren't included that can be added are LEDs, Spark Max controllers, and extra PCM custom circuit boards. All these things are possible to add on into the control system, uh, but you just have to follow the instructions on how to guide on to how to wire them. Okay. So first off, we're going to be talking about the power distribution panel, or the PDP. This is, in my opinion, one of the most important parts of your control system. This is where your motors get their power through the motor controllers. This is what the battery is powering initially. This is also what powers pretty much every single component in your robot. So if you are planning to wire this from the beginning of the your robot, the first thing you would need to do is wire the battery to the main breaker to the PDP. So you'd have to use black and red 6 gauge wire, and then you'd wire the wire from the battery connector to the PDP terminal, and then you'd use the red gauge wire from the auxiliary side of the main breaker, which is the basically the switch of the robot, your power switch, and then you would attach that to the positive terminal on the PDP. So if you look in the bottom left corner of the PDP picture, you'll see these two circular holes. That's where you're putting the wires for the battery. Your PDP also has a set number of slots. You could put so on the sides. You could that's where you plug in your motor controllers or a limelight if you have. You're limited to that number of slots. So also it's worth noting that you cannot add a second PDP to your robot. There were questions about that in the past on Chief Delphi and on my team as well. And it is actually very illegal to have a second PDP. So you're limited to one PDP per robot. So right over here, we have some basic troubleshooting guides for the PDP. This is also available online on FIRST website. Uh, you, if you see over here, it gives basic indications for different lights. So when it's green, it basically means it's a good sign. Everything's working properly. However, when you have orange or red lights, that's when it gets trickier. If you have red lights, which is the worst possible thing, you either need to check your CAN chain, which is usually an error a lot of teams have. There's something wrong with your CAN chain, and that disrupts your whole system up to a certain point. But if it gets even worse than that, there's a possibility that you need to replace your PDP. However, this only really happens if you're really careless in taking care of the board. So, for example, if you get metal shards in it, that could cause it to short circuit, and that's something that could lead to replacing the PDP. Next, pneumatics. So something that a lot of teams are afraid of using when they begin is pneumatics. And I think there's a misconception in some places that pneumatics is really complicated, but that's not true at all. The most complicated part about pneumatics, in my opinion, is understanding the electronic system uh, in it. And FRC makes it fairly simplistic. There are several components in the electronics for the pneumatic side of things, which are the pressure switch, compressor, PCM, and the pneumatic solenoids. All these have to be wired together in some capacity in order to allow you to control your pneumatics. So, obviously, in this diagram, you have a basic guide on how the pneumatic system is supposed to be wired. So, obviously, the all solenoids are supposed to be wired to your PCM. The compressor is also wired to the PCM, but the PCM gets power from the PDP.
Navid, can you quickly talk about your pneumatics debugging methods?
Yeah, sure. So in in the electrical side of pneumatics, something that's very common to get or have damaged is either the can chain or the wires in for the solenoids. So the Wago connectors in the PCM are actually very sometimes very difficult to manage. So sometimes if you're not connecting correctly, they could pop out, especially during a rough match if you're going over obstacles. Other things that could go wrong, as I mentioned, are the can chain, which, if you do not maintain properly, can cause a lot of issues, from shorts to not being connected properly or wired properly. We're going to be talking about the can chain more in depth later on. So if you have any questions, please save them for that section. Something that also is fairly common is getting the pressure switch set up incorrectly. Most pressure switches in FRC are set on default on the pressure that they allow when they are shipped to us or we buy them. But sometimes the capacity that the pressure switch allows you to fill your system to, your air system to, is excessive or above the limit that first allows. So sometimes you need to either change that yourself, which is a hardware issue, or you need to replace the pressure switch.
Okay. Also, what about air pressure? Like they've been using soap to locate leaks. Are there better methods to
Yeah,
make sure there are no leaks inside the system?
So something our team actually has been using soap for our bubbles to check for leaks in the actual system for many years, since 2015 now, I believe. Um, we found that as long as you're careful, that really is the best method to check for leaks, especially if you can't hear it. If there is a very visible leak, or noticeable leak, you could actually hear it. So that's a very simple way to check if you have a leak. But also, if you look at the gauge on your pneumatic system, if the pressure is going down rapidly, um, then you have a leak somewhere in the system. That's your first indicator, really, that there's something wrong.
All right.
So the PCM, as I said before, is the heart of your pneumatic system. This is where all your solenoids are connected to. This is what your compressor and pressure switch are connected to. But this is also not what directly is not directly powered by the PCM. So your solenoids and everything, while they are connected to it, the PCM is powered through the PDP. So it's the PCM is a CAN-based system or a device, and again, we're going to be talking about CAN later on. But this means that, like your motor controllers, your RoboRIO, things like that, this is all connected to CAN. Um, and on this PCM, if you look in a picture, you have 8 slots. This means that you have a max of 8 single solenoids. So to differentiate between single and double solenoids, single solenoids require only a single side of terminal. So a single pair. If you look at 0, 1, 2, 3, 4, 5, 6, 7, it only needs one of those, while a double solenoid needs 2 slots. Because it has, think of it like, if you're more familiar with motors and motor controllers, think of it as a single solenoid is one motor, while a double solenoid has 2 motors. So it needs 2 slots. It's very comparable to the PDP in that regards, and motor controllers. So the PCM is wired to the RoboRIO over the canvas, and it's powered by a 12-volt section of the PDP. So on your PDP, you actually have a spot where it says it's specifically reserved for the PCM and VRM, and that's where you plug this in. Right. So as I was saying before, the PDP is one of the as your heart of your pneumatic control system. That it is the most common point of failure in the electrical side of your pneumatics. So over here is a basic guides on troubleshooting your PCM. If you look at there are different LED signs that say that give indicators on what may be the problem. Again, if it's green, everything's working fine. But if is something wrong with, say, the solenoid or the compressor, the LEDs on these individual slots give you an indication on what's wrong. So you could actually see when a solenoid is activated through the LEDs on each individual slot, which is a very good way of testing if your solenoid is a problem, or is your piston, or just troubleshooting the PCM. You also have LEDs for different states of the PCM, and then the status of the PCM itself. So if you have any issues with the PCM, it's possible that it's the canvas, or it's something wrong with the PCM itself. We actually, in my team, we had to replace our PCM a few times in 2019 because the actual hardware was damaged. But generally, most issues in your PCM comes from the CAN bits, if you have any. There's something wrong with your CAN chain. So the rest of your pneumatics in the electrical side of things are the solenoids, compressor, and pressure switch. So the compressor is what gives you the air you're using on your robot. That you are required by first to now have an onboard compressor if you're using if you're using pneumatics. So but previously you were able to have a compressor offboard and then load your system offboard before the match, which is what 694 did for many years. But starting in 2019, we were required to have an onboard compressor. So we used the most common FRC compressor supplied by Viair, and it's a very there are regulations on your compressors by first, so be sure to check those out. They're specified in the manual if you are curious about that. The pressure switch is what controls the amount of air in your system, or it limits the amount of air in your system. If you get above a certain threshold, the pressure switch is supposed to automatically turn off your compressor. And a solenoid is basically a switch for your pistons. It when it's triggered, it fires whatever piston it is connected to. So all of these are connected on the PCM with 18 gauge wire or larger. Generally on our team, we use 18 gauge wire for most things, especially in the VRM and PCM. So you are welcome to use higher or whatever gauge you feel most comfortable with.
So, a question for the last slide was, how many PCMs do you have a problem with in 2019? And do you have any thoughts on what caused or happened that damage?
Okay.
With that damage?
Yeah. If you want to go back to the last slide while we talk about this, but 694 had issues with, I believe, two PCMs. One was a full hardware problem with it, with the PCM. We never figured out what was actually wrong with it, but after we replaced the PCM, everything was working fine. Another one was because we we were careless in maintaining the cleanliness of our robot, specifically with metal shards, things like that. So that short circuited. Generally, I believe that the PCM is fairly robust in most cases, especially if you take care of it. Like for us in 2019, we actually used two PCMs, and on like the fact that we went through a whole competition season and only had to replace two was, I think, a very good indication of how robust these things are. So I don't think that there's anything exactly wrong with the system. There's definitely things that could be improved. But yeah, I personally feel like as long as you maintain the whole electronic system properly, you shouldn't have any issues unless it's a factory problem. Okay, so the VRM is one of the last major components in your electronic system. So what the VRM actually is a buck boost converter, which is a type of DC to DC converter that has an output voltage that is greater or less than what the voltage that is inputted. This buck boost converter is actually very common in multiple places in the industry. So if you are unfamiliar with them, feel free, be sure to read up on them a little. I feel like they're very interesting. So what the VRM has is two independent regulators, and that again allows for different input voltage compared to the output. The VRM that we use in FRC is limited to 5 volts and 12 volts, and it's wired directly from the PDP. Again, there's a slot on the PDP for the PCM and VRM, and this is one slot is for the PCM. Obviously, this one is for the VRM. The other one's for the VRM. The VRM's main purpose is to power the radio on the robot. Obviously, the radio is one of the most important things. It's what connects you to the field, and it's connected to the radio through 12 volt 2 amps connection. If you look over on the actual VRM, you can see different types of settings in a way. So 12 volt, 2 amps, 12 volts, 500 milliamps, 5 volts, so on. Different devices require different settings. So if you are using the 500 milliamp channels, you connect, specifically for the 12 volt one, you connect devices that require constant 12 volt power but draw less than 500 milliamps. So these are all same thing for the 5 volts. So if you are using other electronic devices on your robot, be sure to check how much power they could handle or how much power they need. Otherwise, you could end up damaging your device. Okay, so motor controllers. Your motor controllers are what actually control your motors. Every single motor on your robot must have a motor controller attached to it. And it's a one-to-one thing. You can't have like two motors controlled by one motor controller. Very illegal. In FRC currently, there are really 4 main motor controllers. The Spark Max, which controls, which is developed by Rev, and controls Neos and Neo 550s. Then you have the Talon SRX, Victor SP, and Victor SPX. The Talons and the Victors are older models and were fairly common, or the most common ones before Rev came out with their line of motors and motor controllers. However, in our team especially, and in most teams right now, a lot of teams have shifted to using the Neos because they're brushless motors, and therefore Spark Maxes are a lot more common. Some quick things about these motor controllers. Spark Max has 2 settings, a brush setting and a brushless setting. Depending on your motor, you need to clarify on the motor controller what type of motor you're using. And if you use the wrong setting, you end up damaging both the motor as well as the motor controller. Also for Spark Max, you have to, there's another wire comparatively that is attached to the motor. So you need to figure out placement a little bit more. So one last thing we're going to talk about before we move on a little, wire connectors. So in the world, really, there are multiple types of connectors that you could use. In FRC, some of the most common ones are Anderson power poles, ferrules, lug compression connectors, ring terminals, fork terminals, twist-on wire connectors, and lever nut connectors, or more commonly known as Wago connectors. The top right picture is a Wago connector, and our team has been using that for CAN especially, or CAN wiring especially. They're very convenient and easy to use, and especially in connecting long systems. So it's I highly recommend using them. We also use these Anderson power poles, which are the middle picture and the top left picture. The top left is actually for a battery terminal, and that is supplied and required by FIRST. But the middle Anderson power poles, those are what we use for basically any other wire that we need to connect. So motor controllers, to motors, solenoids, compressor, VR, sorry, not VR, limelight, things like that. We use these connectors, and because they're so simple to use, and we find them very convenient because it's just pull and pull. Lastly, we use ferrules a lot for connections to things from like the PDP to the VRM or PCM. We just find that they, if used correctly, they last a little bit longer, and they, since they should be there and a done deal once you're put in, we're fairly confident in using ferrules for those things.
All right. So some wiring practices you should practice when you're wiring your robot. First one is you should always label your wires, because when you wire a robot, it's going to get messy. There's going to get a lot of wires, and it just saves a lot of time for what you need to know where a wire comes from, where it starts, where it ends. It's just very convenient if you just label it, so you don't have to just trace it all the way back and forth. When you do wire your wires, you want to try to keep it straight or at 90 degrees. This keeps your robot neat and clean. And always plan ahead before you wire. Don't try to wing the wiring. Never ends up well. You want to have a general idea of where everything goes. And you always want to, whenever you're wiring, you always want to give your wires some extra slack, especially around corners and pitches, because usually when the robot's moving around, everything will kind of shuffle around the robot, and if you make the wire too tight, it could break the wire when the robot's in action. Keep your wiring clean, to tight down your wires, and most importantly, communicate with your fellow team members who are also wiring the robot.
Yeah. Also, just going back to planning your wiring, that's really important, especially for things like the rev motors, because you have to keep the motor controller so close to the actual motor. You have to plan things out, how you're wiring them, and make sure that you're avoiding pinch points where your wire could get cut by edges on your robot. Specifically, if you're using, let's say, an elevator, the game requires some type of elevator, then if you're using a wire guide, then you have to be sure to wire that properly, plan it out, and maintain it. And yeah, just keep things organized.
So we have some questions. They're wondering, how do you guys label your wires, Andrew and Navid?
So we just get a little tape, and write down a little Sharpie. Like, for example, let's say we have some PWM wires, signal wires that are going to the one of the DIO ports on the RoboRIO. We'll just write it down something like on a little Scotch tape, DIO 1, 2, or 3, and just tape it onto the wire.
Yeah. For 694, we just use a label maker, make labels for different components, so motor controllers, RoboRIO, stuff like that. Just label it, easy.
Also, do you guys like for your belly pin layout? Do you guys CAD your layout to plan it ahead of time, or do you guys use something like the cardboard assisted design method?
For my team, 1678, we usually CAD it out, our electrical layout.
Yeah. For 694, we've began starting in 2018, I'd say, to really CAD our electronics and plan things out. Sometimes we've been better at it, sometimes worse, but we always CAD a belly plate, and then we plan our electronics around that and our subsystems.
Yeah. And then Navid, can you also talk about the Wago lever nuts again from the last slide?
Yeah, sure. So these, it's again, this is the picture on the top right corner. These are really easy to use. You just flip up the orange lever really, and then you plug in the wire that you have, and you could connect various wires through the ports. So you could also get Wago connectors with more slots. So I think anywhere upwards to like 5, I believe. There's definitely 3, so I'm sure about that. So 2 slots, 3 slots, 5 slots, maybe, probably 4 slots. I find like that these are just really convenient ways to connect your wires in a very long system. So, for example, if you have a really long CAN chain, I think these are a great way to keep up the connection and make sure ensure that they won't get loose.
All right.
All right, so what you see here is the RoboRIO. And the RoboRIO is the basically the brain of the robot. It's a CPU. As you can see here, has a bunch of different ports for for different electrical components. You got DIO, PWM, CAN, relay, and analog. And yeah, this is just basically some more ports. You got your USB device port, USB host ports, Ethernet port to connect to the to your computer, your power port, and the RSL port for the robot signal light.
Quick question again on the Wago lever nuts. So essentially, it connects 2 wires quickly, correct? Navid, you're muted, by the way.
Sorry about that. It's more accurate to say that it's an easy way to connect wires in a long chain. Um, so again, if using the CAN chain example, if you are connecting the CAN chain from, let's say, the PCM to the, I don't know, another motor controller in the opposite side of the robot, and you need to extend the CAN chain. So I feel like it's a great way to extend that wiring.
Okay. And then, okay, so I'm gonna move on to the next slide.
All right, so powering the RoboRIO. So the RoboRIO needs an input of 7 volts to 16 volts to function normally. If the voltage drops below 7 volts, so RoboRIO will enter a brownout mode. And basically what happens in a brownout mode is the RoboRIO is trying to basically survive. And it'll stop certain functions. And if you drop below 4.5 volts, it will complete all functions. And basically, if you look on the picture on the right, it's basically a table of what happens when it drops to certain voltage. The RoboRIO status light is located on the top right corner of the RoboRIO. It basically indicates stuff about the RoboRIO. The top one, as you can see, indicates power, and it's basically telling you if the RoboRIO is receiving the correct amount of voltage. The status light shows whether it is running its the status light shows the status of the RoboRIO. And then the radio and comm shows if it's connected to the driver station, and the light, the comm status light indicates the robot's communication conditions. And then the mode indicates whether what mode the RoboRIO is in, and the RSL signal light is identical to the actual RSL. You can see on the table what each color and state means, and you can find all this in the user manual. It's really handy. The indication status LEDs are really helpful when something's wrong with the RoboRIO. It's a quick way just to assess the issue. So one signal system that the CAN supports is CAN. Sorry, one signal system that the RoboRIO support is CAN. It's the CAN bus. It stands for Control Area Networks. Control Area Network, and what it is basically there's a CPU with a bunch of nodes, and they're all connected through a bus. And what each CAN node has is CAN transceiver, CAN controller, and microcontroller. What the CAN transceiver does is receives and sends signals from the CAN loop, and the CAN controller basically converts the signals into information that the node can use, and the microcontroller just performs all the functions of the node. And how the CAN works is this Dixie chain. So basically, each one node is connected to the next node, connected to the next node, connected to the next node. It's not like where it has a central processing unit and everything connects to the central processing unit. It's just connected next to each other. And as you can see the picture here, you can see what each CAN node should look like. It's a CAN transceiver, CAN controller, microcontroller. And this is what a CAN loop should look like with the each node connecting to each other. And as you can see, here's another picture of what CAN loop is supposed to look like. As you can see, without CAN, everything connects to the central processing unit. But with CAN, it's just a Dixie chain where everything's connected right next to each other. And on the right, you can see the a bunch of speed controllers connected with CAN. Basically, CAN makes it's cleaner. It's easier to wire compared to wiring everything to the RoboRIO. So the three main components you need in a CAN is the RoboRIO, the PCM, and the PDP. And again, they're daisy chained. And what's important about the PDP is that it has terminal resistors on it. And basically what it does is it prevents signal reflection into the CAN bus. This prevents it from messing with the signal. A useful component to use on CAN is the canifier. What the canifier can do is it basically converts like digital or analog sensors into the CAN loop. And it can also be used as an LED driver to control LEDs. The canifier eliminates needs for some sensors to be directly wired to the RoboRIO and adds sensors into the CAN loop. But if you are going to use a canifier, you're going to have to you have to put a terminal resistor on it and set it up as one of the terminating resistors. So that's a typo. I think it's supposed to be an I2C. It's a simple protocol to talk to sensors, but it requires some tricky programming. I don't think it's used often in FRC Robotics. So essentially how I2C works is there's one master controller and 3 slaves. And it can be used to control LED drivers and digital sensors. And that's just a picture of how it works. Yeah, and again, it's not used very often in FRC. So another signal system is the DIO. It stands for digital input output. It's a control type that you can use for sensors. It uses 3 wires, a ground, voltage, and a signal. The DIO can either output a 3.3 volts or 5 volts, depending on the sensor, or 0 volts. Basically, this is the RoboRIO will receive this information as either 1 or 0. So sensors with digital input output DIO will only have 2 statuses, on or off. So it can basically say it's on or off, and 2 values. And sensors like the proxy sensors, limit switches, and Hall effects use DIO. Another signal system is the PWM. It stands for pulse width modulation. It's a way to approximate analog signal. It consists of cycles of full voltages and no voltage. And it works by controlling the amount of time the voltage is being outputted. By doing so, it can simulate a lower amount of voltage being constantly outputted. The width of the pulse, or the percent of time that a voltage is being outputted, is called a duty cycle. So basically how it works is that if a 50% duty cycle would mean that voltage is outputted only 50% of the time, this would make it seem like 50% of the voltage is being outputted all the time. So let's say I'm sending 5 volts, and during a 50% duty cycle, that would make it through PWM. It would seem like it's sending 2.5 volts all the time. And uses the same signal wire as DIO. So relay. So how relay works is basically it uses a small voltage to control components that need a big voltage. You could use this on spike, bridge, and relay from Rev Robotics. It could be used for motor control, like full forward or full reverse. So MXP expansion boards. So depending on how many sensors you're using, you may want more ports on your RoboRIO than there actually are on the RoboRIO. So in that case, you want to use an expansion board. The MXP, or MyRIO expansion port, is a port on the center of the RoboRIO where you can plug in expansion boards. There are many different types of pre-made boards, as you can see on the links on the slide, that you can choose from that would fit your need. You could also make your own board. You can also make your own board, but they can only expand signal ports, and they also need to be approved by FIRST. And this is just what the expansion port looks like. All right, so let's move on to sensors. So a sensor is a device that detects or measures a physical property and records or indicates it, and then sends it out as an output. So it would measure like something like a distance, or record it, indicate it, and then send it out to the RoboRIO, and which will send it out to the driver station. So why use sensors? Sensors have a lot of different functions. For example, it could give feedback on positioning of robots, like it's like if you have a wrist, it can tell you what angle the wrist is at, or moving the robot. Also, you can use it for motion control, like how fast the robot is moving, and detecting field elements, like just detecting the surroundings, detecting stuff on the robot. Okay, so choosing a sensor, so when you're choosing a sensor, there's a lot of factors you want to factor in, such as the sensor output. You want to, depending on what you require on your robot, there's a variety of sensor outputs they can choose from: Boolean, analog, and digital, serial. You also want to consider what you're using a sensor for, like distance detection, optical condition, speed, accuracy, precision. You don't want to have a sensor that just everything. You want one that fits your purpose. And finally, electrical requirements. You also have to consider what your robot can give out for voltage and current. All right, so some examples of sensors are one type is the limit switch. Limit switches basically just it's a limit switches can be used to detect when a mechanism has reached a certain point. Basically, it's like a little clicker, as you can, as the top sensor and thus on the slide. It's basically like a little clicker. Once you press down on it, it completes a circuit and it sends a signal. You can use this to detect field elements, but it has a potential for mechanical failure. So, which brings me to the next sensor, which is the Hall effect. And how it works is that it detects magnetic fields. So, if you have a wrist or something, you can attach a magnet on it. You can detect the swing back and forth. You can also use this to replace a limit switch, and yeah. Some more examples of sensors are encoders. What these do, they can measure rotational positions and rotational rates. So what you can see here on the top right is a mag encoder. Basically, it measures the polarity of the magnet. So it measures basically rotational spin rate. So you can use this to measure your speed of the robot. On the bottom is a sort of a type of encoder. It's called potentiometer. Potentiometer. And what it does, it's really good for measuring rotational position. So say you have a wrist that you need at a certain angle, you will want to use this to put it at a certain angle. Some more examples. Gyroscope. Gyroscope is used to measure angular motion. It can be used to tell the direction your robot is heading and keep it pointed in a certain direction while driving. Accelerometers measure acceleration. They're most commonly used to measure robot tilt, and in that case, they are measuring the acceleration due to gravity. The RoboRIO has some built-in accelerometers, but they're not very accurate, and I would recommend you getting an outside accelerometer. Proximity and beam break, they are used to detect distance to an object, or if there's like an object in front of it, in the case of the proxy sensor.
Andrew, I was wondering if you could maybe explain how you've used some of the sensors on your robot design. Like, for example, how have you used the encoders and the potentiometers?
All right. Coders are most commonly used for on our drivetrain. Basically, it tells us basically how fast our robot is going, and yeah, it gives us information about it. The potentiometer, again, used for angles. We use it on the wrist. We use them. We use it on our wrists to kind of like lift game objects at a certain. If we need to lift game object at a certain angle to score it, that's what we'll use it for.
And then what about the Hall effect sensor?
Hall effect sensor we use in place of the limit switch. So basically, if let's say we have a mechanism, right, and we need to know if it's closed, we will put a magnet on the end, right? And so when the mechanisms like an arm or something is closing, the magnet will come close to the Hall effect, and the Hall effect will detect the magnetic field and it will indicate that the arm is closed.
Okay. All right. Thanks. Navid, do you have any comments on some sensors that you've used on 694?
Yeah, so on 694 we used the beam break proximity sensors a lot, especially in the last few years. So basically every single intake we've had since 2018, we've been using the beam break for it to detect the game elements. We also use them on our uh, elevators to detect when we're at our lowest points or things like that. We also use limit switches a lot, again, for just basic booleans for detecting if say our elevator is again at all the way at the bottom or all the way at max height, things like that.
All right. Okay.
Sensor boards. There are two examples of some sensor boards: the Gadgeteer Pigeon IMU and the FRC Gyro board. Basically, the gyroscope and accelerometer. They also include some other sensors like the magnetometer and the and temperature thermometer. You can use the sensor board to expand your robot's capabilities and improve its performance in competition. Basically, going back to what I said earlier about how the accelerometer and the RoboRIO is not very accurate, this is what we would use in replacement. So, implementation of sensors. So when you're mounting your sensors, you want to make sure it's in a protected place. You want to make sure that nothing like will hit it or is like render it unfunctionable. The sensor also must see the target. Basically, it must not be like blocked in order to prevent it from performing its task. So, for example, if you have a proxy sensor, you don't want to put anything in front of it to prevent it from doing its job. You want to make sure when you mount it, it's secure. It also has to be easy to remove and replace the sensor. And the wires to the sensor should also be a connector, not soldered, so that way you can also easily remove that. You also want to mount your sensors in a place where there's not a lot of noise, magnetic and electric. So that means not mounting it close to motors, because motors' magnetic fields can interfere with delicate sensors. Also, high current wires can also interfere with sensors. And the best way to prevent this is if a sensor seems like it's not working or it's inconsistent, you want to move it away from things like motors and radios. Faraday cages can help with electrical field noises, but it would not help with magnetic field noises. So implementation of sensors continued. There are three interface types you can use with sensors. I've gone over some of these earlier, but they are DIO, digital input output, analog, and digital serial. So DIO, or digital input output, has two possible values, and it can be read as a 1 or 0. And it is very straightforward, really easy to use. Analog signals contains a bunch of values in a very wide range, which means they provide more information than DIOs, but are very susceptible to electronic noise. Digital serial is a string of digital signals. It is very precise, carries a lot of information, but is very difficult to use.
Okay, so the future of the FRC control system. In February of this year, first announced that there's going to be a new system starting from 2022 to 2026. and it's primarily provided by National Instruments and Rev Robotics. So National Instruments will be continuing to provide their RoboRIO, but it'll be releasing the next generation with increased RAM and flash memory, improved low voltage protection, and high speed grade zinc processor. I think personally the most important thing is the low voltage protection and increased RAM and flash memory. It should mean that you could process things faster and your handle more robust calculations, and it just is makes your whole RoboRIO a bit more robust. Uh, on the flip side, CTRE won't be um, supplying the rest of the modules. It'll be Rev Robotics, who mentioned before develops the Spark Max and the Neo. So the new power distribution hub will be have 20 channels compared to the 16 now, and all of them will have a 40 amp load capability. Right now, there are two loads on the current PDP, so this is a big improvement. The pneumatic hub also gives you four more solenoid channels compared to the current eight. And then the voltage regulation hub is still 12 or 5 volt module options, but instead of two output channels, there's now three. And there's also a new radio being worked on, which is what I believe needs the most work in the FRC control system, but they haven't specified who's actually producing it. I believe like one of the biggest changes is that it's not going to be called modules anymore. They're all hubs. So I think that's very interesting choice. But I think that the future of the FRC control system is going to continue to develop to be something that is both easy to use as well as very representative of the industry. So I'm really looking forward to what first and these companies release in the future.
Also, we have a question asking, does the increased low voltage protection mean that it will operate down to a lower level?
Um, could you elaborate on that question a little? Sorry, I don't think.
Yeah, I'll wait for them to elaborate. Brent, can you please elaborate on your question? Yeah. All right.
I'm gonna assume you're referencing the mounting the implementation of your sensors. Um, I would say I actually don't know about this. But yeah, I would. Yeah, I don't really know anything about this.
So just to say quickly, I believe what it means is that it allows you to. It does, I think, provide some protection on like low voltage and then shutting down and brownouts and things like that. But I think it just makes the whole RoboRIO a bit more robust and capable of using different sensors, things like that.
And so that concludes the RoboRIO wiring and sensors presentation. So hopefully you learned something today. Thank you for joining us. So, see you guys later.